Trigonometry, Chapter 6, Inverse Circular Trig Functions and Trig Equations, Section 2, Solving Trig Equations, Video 3, Basic Quadratic Trig Equations, Part 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned to solve basic linear trig equations. We isolated the trig function, then determined quadrants and a reference angle. We found solutions within one period, and then found general solutions. In this video, we will learn to solve basic quadratic trig equations, plural. A basic quadratic trig equation is an equation that is quadratic in one trig function, such as 2 sine squared theta plus sine theta minus 1 equals 0. By the way, a non-basic one would have two different trig functions, which we'll address in a future video. When solving such an equation, it helps to make a substitution. A substitution is when we choose to replace a repeated expression within an equation with a single variable. We solve the new equation, then undo the substitution and continue solving. Heads up for those of you who are either in calculus or heading towards calculus. At some point in calculus, usually towards the end of calculus 1, substitution becomes a critical move that never goes away. Now for this equation, we're going to make the substitution sine of theta equals u, because sine of theta is repeated in the two terms. Yes, on one of them it's squared, but that's easy to fix. Any variable will do, by the way. U is common when making substitutions in calculus, but any letter besides theta, because that's already spoken for. Now, if we let sine theta equal u in the equation 2 sine squared theta plus sine theta minus 1 equals 0, it becomes the new equation 2u squared plus u minus 1 equals 0. Each sine theta became a u, everything else stayed the same. 2u squared plus u minus 1 equals 0. At this point, you solve the new algebra problem. Now, you are expected to be familiar with ways to solve quadratic equations, such as factoring or the quadratic formula. I will be utilizing both and a third technique in this video and the next one. You can solve 2u squared plus 1, you can solve 2u squared plus u minus 1 equals 0 by factoring the left side of the equation to get 2u minus 1 times u plus 1 equals 0. Now, I know not everybody's factoring skills are where they ought to be. If they're not there, you need to take means to get them there, because at this stage in the game, factoring should be a non-issue. Now, since the equation is now factored on one side and 0 on the other, we can set each factor equal to 0. We can set 2u minus 1 equals 0 and u plus 1 is equal to 0. Quick comment. This split move only works when it's factored and equal to 0. No other number would allow you to split the factors. If this 0 were any other number, we could not make this split move. A lot of people like this move and use it when they're not supposed to. You can only do it when it's factored on one side and 0 on the other. Excuse me. Now, both of these linear equations, 2u minus 1 equals 0 and u plus 1 equals 0, should be trivial to solve, so we're not going to dilly-dally. The first one gives us 1/2. The second one gives us -1. Now, once you find the values of u, change u back to what it was representing, which was sine theta. So each u now goes back to becoming a sine theta. And now we just solve both of these basic linear trig equations. Yes, like in the previous videos. For sine of theta equals 1/2, sine is positive in quadrants 1 and 2. Now for sine of theta equals -1, this didn't show up in the previous videos, but -1 is the value of sine at 3 pi over 2. This is a quadrantal angle, and I didn't mention in the previous videos about solving basic linear trig equations that if your value indicates that you are at a quadrantal angle, pi over 2, pi 3 over 2, 3 pi over 2, or 2 pi over 0, in other words, on the positive or negative x or y axis, then you don't do the whole reference angle shtick, you just get the angle. Now, for sine of theta equals 1/2, we do have to find both solutions in quadrants 1 and 2. Well, the reference angle would be sine inverse of 1/2, which is pi over 6. And if we put that in quadrant 1, it is its own solution. And if we put it in quadrant 2, we would subtract it from pi to get 5 pi over 6. Now that we have our specific solutions of pi over 6, 5 pi over 6, and 3 pi over 2, the general solutions are theta equals pi over 6 plus 2 pi n, theta equals 5 pi over 6 plus 2 pi n, and theta equals 3 pi over 2 plus 2 pi n, where n is an element of the integers. So in summary, you basically take this quadratic trig equation and make it not trig with the substitution, solve the algebra equation. By the way, we could have used the quadratic formula as well. Undo the substitution and then proceed to solve like we did in the previous videos. There is no now you try for this video. It will follow the next video.